Yes, let's look at differentiation. Differentiation, if you're having a function of x of the form x to power n, where n is any real number, how do we differentiate? So the derivative, we shall represent it with f prime of x, and what we do, we drop the power of x, meaning n comes down, and then reduce the power of x by 1. So subtract that by 1 and you have the answer. For example, if you have our function of x equaling to x squared, then how do we differentiate this? So our f prime, which is the derivative, will be equal to, we say drop the 2 drops, and then reduce the power of x by 1. So 2 minus 1, which gives you 2x to power 1, which is a 2x. So later on we shall understand that when you're getting the derivative of a function, it's like you're getting the gradient of a given function. Okay, and the gradient we know is always equal to change in y over change in x. So we shall later on denote the derivative as dy dx, where y will be a function of x if y is equal to a function of x. So actually it means that dy dx will always be equal to the first derivative of x. So for example, if you're given a function y equals to x to power 4, so we get dy dx equals to, we say drop the power of x, so the 4 drops, so we have x, reduce the power by 1, you have that, which gives you 4x to power 3. So that is dy dx. Okay, we can look at more examples. Another example, if you have y equals to like 2x, where the power of x is 1, or if you have a linear function like this one, then this one, the derivative, for example, this is like x to power 1. Okay, so when we get the derivative, we say this 2 drops, I mean the power drops, so when it drops it multiplies with this constant. This coefficient, we just always keep it there because it is independent of x. Now we consider only this. Okay, so since there is multiplication here, a silent multiplication here, when 1 drops it multiplies with the coefficient of x, that is 2. Then what remains? This remains, we said reduce the power by 1. So it means we get 2x to power 0, and any number to power 0 is a 1, so which is 2 times 1, giving you a 2. So whenever you differentiate a function, for example y equals to cx, where the power of x is 1, this c being a constant, then the derivative will be the coefficient of x, meaning c. For example, if you have y equals to negative x, the derivative here would be negative 1, because the coefficient of x is negative 1. Yeah, if you look at another example where our function is a constant, for example, if you have a function as y equals to 3, in a case where y is equal to 3, this one is like a straight line, like the values of x are the ones that differ, but the values of y don't differ. So it means that if you are getting the gradient of such a line, let me just show you. For example, if this is a Cartesian plane and this is point 3, it means this line will be that line, y equals to 3. So the gradient, like the values of x, will vary. For example, if I choose those points, but the coordinates of y will remain the same, it will be 3. So if you are to get the change in y, like getting the gradient, y2 minus y1 over change in x, whatever change you get in x, this would be 3 minus a 3 over change in x, which is a 0. So when it is a constant, we expect that the gradient will be a 0. So that's why we say that the derivative of y is equal to 0. So if you have y equals to 3, it's the same as having y equals to x, 3 to power x, 3x power 0, because x power 0 is a 1. So like if we are to differentiate, this is 3 times 0, the 0 drops, so the power of x reduce it by 1. So by having here a 0, it already takes everything to 0. So if you have any constant, like a function is a constant, like y equals to 4, then its derivative or its gradient is a 0. So if we look at examples, like if our function was 4x minus a 5, then we are having a combination of functions. We have this one that is a line, it's not a constant, but this is a constant. So you differentiate them differently and then you add up. So like this one will give us 4, and then minus a 0, giving you a 4. If you have a function like y equals to x squared minus 4x plus 6, so our derivative will be, differentiate each function at a time. When you differentiate this, it will be 2 reduce the power by 1 to remain a 1, minus this will be, we said if it is something like when the power of x is 1, you take the coefficient, so that will be minus 4, then this is a constant plus a 0, so remain with 2x minus a 4. Yeah, so don't forget to subscribe for more lessons that are coming. If it has been interesting and important to you, feel free to share it to your friends and subscribe for more videos that are coming. Wait on the next episode.